Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Hello and welcome to MLOps Live. I'm Sabina, your host, and I'm joined by co-host Steven. So this is an interactive Q&A session with our expert in today's topic. It's our pleasure to introduce Jacopo Tagliabue, who has even been called the father of reasonable scale MLOps, definitely a machine learning rock star. So Jacopo, could you introduce yourself a little bit to our audience?
Of course. First of all, congratulations for the pronunciation of my first name, but especially my last name, which is almost impossible for anybody outside of my country. So I don't know what's the trick there, but congratulations, for that. Thanks so much for the awesome introduction. I'm not sure I'm the father of the reasonable scale MLOps, which is also a very niche thing. So it's not being father of a lot of stuff. But I'm very happy to be here. Thanks so much, guys, for having me. So I'm currently the director of AI at Coveo. For those of you who do not know Coveo is a publicly traded company on the TSX. And what we do, we basically provide machine learning models to customers to serve different type of use cases. The things that I know the most is e-commerce, because I come from there. And so the idea is that, let's say you have a website and you want to power your website with smart recommendation, then you will ask basically Coveo to provide you a model to do that. This is important not so much for, of course, for telling you a bit about myself, but it's going to be important in the next hour to kind of tell you where we come from with the reasonable scale ML, as we're a B2B company. So we do not have customer using models directly, but we provide customers with models to use on their shoppers or something like that. So I think that's an important distinction to be made. I joined Coveo to the acquisition of my company, which was called Tuso, which was doing pretty much the same thing, natural language processing and AI for e-commerce in San Francisco, with my co-founders Ciro and Mattia. So I'm a former entrepreneur as well. And I like also to be part of the research and academic community. I am an adjunct professor at NYU, where I teach machine learning systems. So actually how to put together all these machine learning pieces to make them work. And I try to contribute to the e-commerce tech community as much as I can with my team, with papers, open source, and data.
Excellent. Thank you so much, Jacopo. So we are all very eager to start asking questions about your work and tap into your knowledge. So just to warm you up, Jacopo, how would you explain reasonable scale MLOps in 1 minute?
Sure. So a lot of the ML guidelines and kind of ML practice that we read every day, in blog posts or Harvard Business Review or whatever, are kind of like Google did this or Facebook did this and you should do this. And reasonable scale ML is the idea that you're not Google and it's okay. Like, it's totally okay. Like, it's totally okay not being Google. Actually, the vast majority of use cases of ML in the near future are going to be like inside enterprise or in company that are not necessarily big tech. So that's a context for reasonable scale. But the exciting part of reasonable scale is that thanks to the growing and blooming ecosystem of open source tool or solutions like Neptune, for example, that are like now available for everybody, with a very low barrier to entry, it's possible to do cutting edge ML at reasonable scale. So this is a huge difference because like 4 years ago when we started Tuso, my own company, a lot of things that now we take for granted were not there. And so you needed huge resources to make that happen. But now, for the first time, if you start with a small team or with someone not so much resources, you can still make very good ML. Again, thanks to this incredible ecosystem. So what we're trying to do is to evangelize people. I mean, this is not even our own business, but we try to evangelize people of what worked for us to help them kind of like go out of this idea that doing ML in production is super complex. It is if you don't have the right tools. It is not if you know what you're doing.
And just for a follow-up, Jacopo, I'm wondering what really happened at, say, Coveo or your previous company, a company you founded, that made you start thinking about reasonable scale, and so what's the story behind that?
Yeah, absolutely. So as we said before, remember, B2B companies are very different than B2C company. So a typical B2C company is an ML stack for Airbnb or let's say Amazon, let's say in e-commerce, Amazon, right? Okay, they have one recommender system to simplify, but they have one website to handle. It's a very huge and very important website and very hard. But at the end of the day, they control this website end to end, right? And every time they make a small improvement in the recommender system, they're gonna pocket the difference in whatever money they're gonna make, which in the case of Amazon is billions of dollars. We justify the investment of doing that. B2B companies like Tuso or Coveo kind of have a different way of growing. We grow by adding customers, right? So our ML needs to be, of course, good, but we need to optimize not for one specific client, but for robustness across, literally hundreds of them. Okay. And then when you go to each of these customers, each one of them is not going to be Amazon. Maybe all together they're like terabytes and terabytes of data, but each one of them is, a reasonable scale customer, has millions of events per day, not trillions. Okay. And so the idea is that, of the reasonable scale stack came from the business realization that most of our business problem are per customer or per organization. And most organizations in the world are reasonable scale organization. Most organizations in the world are not Amazon, as a matter of fact. And we want to help them as well. I mean, there's no reason why you don't have good ML just because you're not Amazon. That's kind of the too long did not read tagline of all this.
And talking about Amazon, Google, and so forth, these are like hyperscale companies, like you've mentioned. So what's like the biggest difference or differences you'd say if you're setting up ML for a small company of, say, like 4 engineers or 2 data scientists versus like an Amazon scale? What like the differences you could point out that will help?
So I think so. One is like the first one, which is going back to my previous remark, is difference in incentives. So there's a difference. Like if you're at Google or Amazon, there's an incentive to be marginally better at something because the 0.1 improvement on X is going to translate in billions of dollars. This is not necessarily true for a reasonable scale company. So on the incentive side, the way in which you structure your team, for example, how many data engineers, how many data scientists, how many machine learning researchers you have, kind of depend from this, business constraint. And the second point is the build versus buy versus open source versus whatever you want. But it's kind of the idea of how you use your resources. Like if your resources are constrained in some way, as you said, 4 engineers or 2 data scientists or whatever, you really want to spend the vast majority of your time, possibly all of your time, doing high value, high margin activities. Okay. So for example, if you're a data science building a recommendation model in Coveo, I want to be doing recommendation models. Okay. I don't want to deal with infrastructure, scaling, experiment tracking, you name it. We can name them, all of them. And so it's much better for me to buy or somehow to leverage something else that is already very good in one of these things, which is not my core. They're necessary to do my job, but it's not what I do. And then I can focus on the best type of things. At humongous scale, like Google and Facebook, they already solve all of the ancillary problem because they're so important for them. They may not use other providers because, there's some peculiarities to their level of scale. But most reasonable companies are actually similar in that respect. As in, if you use Metaflow or whatever, Snowflake at Coveo, I'm sure you can use it to a very similar company with mostly the same kind of like patterns.
Yeah, so we have a question now from the audience, from Chris. Go ahead, Chris.
Hi. So very interested in this series. So I'll be on every other week, I think, as we try to figure it out. So I appreciate, Jacopo, I appreciate your definition of B2B versus B2C. We sell to other businesses, so we call ourselves B2B, but really we're B2C, right? Those are just customers. We have our own product and we have an interface. And I say that to frame out, help maybe with your answers. So we're at phase 0. I'm a machine learning engineer, brought in only a couple of months ago. spent all my time doing software engineering so far. But I am tasked with trying to figure out what I think is the most important piece of machine learning experimentation as a small data science team continues to try to advance the 3 commercialized data science models we have today. So the big question is, we're an AWS shop, and so I'm struggling with the MLflow, SageMaker, Neptune platform paradigm to get started. Clearly you're Neptune, so how did you get there?
So you're talking just about the experiment tracking part, or the entire pipeline of like how you help your data scientist? You just want to focus on the experiment tracking?
I got to take small bites, right? I think it's a mistake for a team of 3 to try to do it all. So,
yes.
AWS would like us to just sign on it and do it all. I'm not yet sold on SageMaker experiments. I'm not yet sold on the cost of a small company taking on the resource requirements of MLflow, although we have that stood up on Kubernetes on AWS. So yeah, we're there. Small bites. So right now we're talking model experimentation, get that under control, get better visibility inside the team of what each of us are doing to our primary core components.
So for experiment platform, so I will go back to the general point like afterward, but let me answer this specific question first. For experiment tracking, I am familiar like intimately with Neptune, like weight and biases, and Comet. And they're all great in products. I think they cater to slightly different type of users. But the general suggestion for me is I pretty much prefer the SaaS experience that like Neptune provides compared to MLflow. Not because MLflow is not great, we used that before as well, but because it doesn't justify the additional maintenance and kind of cost of ownership for such a feature in our team, which is kind of heavy on cutting edge experiment stuff, and not so much on infrastructure and bare bone maintenance of stuff. So I think the very first choice here you have to make is between something that you host yourself for experiment and one of these tools, depending again, it's slightly different in who they caters to, but like one of these tools in how they actually solve the problem, experiment tracking and model registry and so on and so forth. In my opinion, this is a no-brainer SaaS thing. So this is one of the things that especially small teams should go SaaS with. But I understand that some other people may have different constraints on security or all sorts of other problems. But if you ask me, this is SaaS. This is 100% buy. There's no universe in which this is build it yourself kind of thing.
Yeah, I think phase 1 security is our biggest concern because it's all PII in the sense of the company's customers and customers, and so it has to be behind our VPN. And we hadn't opened that conversation with Neptune yet on costs and complexity to get that set up.
I super totally understand that. Remember, then you can, with all this solution, as far as I know, but people on the call correct me. With all this solution, you can start like for the experiment tracking part. There doesn't seem to be much sensitive information that you need to send to get value out of this tool actually. So it's more loss metrics, aggregate metrics, and evaluation. So I think for all of this tool, even a SaaS adoption can be a journey. When you start with something that is heavy on the light on the security side, but still provides value for your experimentation cycle, and then the more you build, the bigger appetite you kind of build up. You know what I mean? So I think there's a path here to have a short adoption circle, see how it goes, and then postpone the security discussion for when you need to upload artifacts or data or something like that. Does it make sense?
A lot. Thank you. Yeah.
Okay. Another thing that I want to say about AWS is that there's a tool that we really super suggest. It's open source, so nobody's getting any money out of that, and it's called Metaflow. We actually have several open source repo. If you check my GitHub, there's several open source repo that shows you how to kind of build an entire system end to end. And like for people using for using AWS, we always find Metaflow as a good kind of like a backbone on which to put on top, like Neptunes and then SageMaker for serving or Seldon or whatever you need. So my suggestion is, if you're already sold on AWS It doesn't mean you need to go the entire SageMaker way. You can, again, pick and choose some other open source tool that are very good in kind of making you productive.
Yeah, we have actually a follow-up question in chat about Metaflow. Is it ready for Kubernetes or not? Can you comment?
I cannot say officially because I don't know the latest release. I think I can say it's in the works. I don't know if it's already like out or if it's in beta. What we use it though is with AWS off-the-shelf computing. So for us, it's not a big deal because we're using that on top of AWS Batch and AWS Lambdas, which are already part of our kind of infrastructure. I think the Kubernetes thing is interesting because a lot of people kind of use that, of course, as the existing backbone of their infrastructure. I think there's a nice post by Chip saying data scientists don't need to know Kubernetes. And I will go one step further. I'm going to say a lot of ML team don't really need to use Kubernetes at all. At reasonable scale, there are, as good solution as Kubernetes to run your computing, your training, and your serving, probably with a fraction of the maintenance headache of actually going to Kubernetes. So irrespective of what is the status of Metaflow and Kubernetes today, and I'm sure that's gonna improve, but we never had any problem of actually running Metaflow with using AWS PaaS services, and we're actually very, very, very bullish on the idea of using these PaaS services instead of maintaining a cluster ourselves.
Right, and just as a follow up on Chris's question as well, you talked about the end-to-end side of things, like reasonable scale teams thinking of the end-to-end side of things. But I'd say with reasonable scale, you're thinking of one thing at a particular time, and then moving on to the next thing, thinking about the next. So how do you think about what component to put in first when you're building like reasonable scale, especially if you have like 2 data scientists on your team or like 4 engineers? How do you start thinking about the first components to work with to start building that stack out?
So the first thing to do, like the first thing you need to do for your first ML project, the first rule is always never do ML if you can. That's usually so. Like to get the feeling of how an ML feature works, let's say a recommender system or a case classifier, like a sentiments analysis or whatever. The vast majority of value is going to be in the data, especially on a reasonable scale, where again, marginal difference in model will make less of a difference in your business outcome. Okay, so if your team is small, I would suggest starts with the data, make sure that it's that it's clean, that that is properly stored. We can discuss how to do that, and then you can work on this data to produce a small endpoint. That at the very beginning, it doesn't need to be an ML endpoint. It can be a set of rules. It can be the stupidest model you can think of. It can be a bag of words with scikit to do test classification, okay? And then make sure that things work end to end. The things work from the data to your model to the prediction. And then you can capture whatever feedback is your use case about. Let's say if it's a recommendation, it's a click. If it's a text classification, maybe it's a thumbs up or thumbs down if the user wants to leave a review or something like that. Once your 2 data scientists knows how to go from data to clean data, to model, to endpoint, and to feedback, once all these parts is in place, they're all decoupled. So as long as you maintain the contract between these parts kind of intact, now you can start improving. Now we remove the bag of words and we have BERT or whatever you want. And now, we make data quality better. Instead of just checking, how much data we have, we can use great expectation to check distribution or whatever. Like, you know what I mean? So start small, but start small in a thin slice. Like, because if you start small but focusing only on one part of this, you kind of lose focus on the problem that what you need to solve is end to end. It goes from data to user and then back, from user feedback to data again. So I think that's the most important. Like what we try to do is kind of always prototyping a thin slice of a feature, and then you go back and you improve all of that. You improve at will. Like, you can improve for months. But the first thing is, spend as little amount of time as possible to get something out of the door. And is it possible if you use good tools? Like if you use, SAS experiment track, if you don't waste your time in kind of dumb stuff. Okay, so that's very important.
So tools that help you get things out faster, like, prototype as fast as possible.
Yeah, exactly. Don't think the amount of time you think about, let's say, buying a SaaS experiment platform is gonna cost more at the end than if you just sign up for it, use it for a month, you ship something and you see how it works, and then you decide. It's really important. But again, this is come from a very specific way of kind of building, again, reasonable scale company, and come from a very startup mentality when you continuously iterate. So where velocity is a virtue. I do understand that that's not true in all contexts, and of course, I wouldn't suggest to do this for healthcare or autonomous vehicle. There are places where moving fast is not a value, but there are a lot of places where actually moving fast is a significant component of being good at ML.
Awesome. Sabine?
Yeah, we have a question in chat by Robert. He has some data privacy concerns here, and he's asking if you have any recommendations about tooling to set up a full MLOps pipeline, except serving maybe for like a small ML AI team, 3 to 5 people, with the hard requirement to run on premises. They have some GitLab CI and DVC already set up and running.
So unfortunately, or fortunately for my life, e-commerce is a very non-sensitive area of data, because e-commerce data is always hashed or anonymized in the first place. So a lot of the data we deal with as interaction data, or what people do on a website, as normal security constraint, but it's not like healthcare, or it's not particularly sensitive. So once you're complying with GDPR and general regulation of how data is handled, your work as a data scientist is somehow somehow made easy by the business case. So I don't have huge experience in privacy first environment, unfortunately. I know DVC is great, but all our life is a life about cloud and services. Kind of pitch of the reasonable scale stuff is cloud and services are good, as in they allow you to move much faster than if you have to maintain stuff yourself, with the obvious implication that sometimes where it's not possible, you have to go in on-prem and do things yourself. But I don't know the use case in particular, but another thing that I found in my experience that a lot of people tend to drastically overestimate the security of their own setup as compared to cloud provider or SaaS provider that offer the same, if not better, security if somebody actually were to look into that. Again, I don't know these specific use cases, but I know other cases in other sector when the resistance to move to the cloud is more cultural than actually a factual problem about the cloud being not secure in whatever definition of secure or private it is. So yeah, I don't know. So maybe in this case, setting up a good data governance for data set or for data access or for Snowflake or Metaflow, whatever, maybe a way to kind of make this privacy concern a bit less heavy.
Right. And at this point, we can throw in a bit of a shout out to Alfredo, who shared a link to some MLOps education material and tools in the chat. So thank you, Alfredo, and have a look in chat, people, if you're interested. We then have a question about a different topic. Piotr in chat would be interested if you can share, Jacopo, how do you deliver models to customers? Do they use your API or does it work differently? And how do you know how the models are performing in production, and how do you know when to update them, for example?
That's two very good questions. So for the first question, I'm going to split between two. One is, let's say, prototype or internal deployments, and one is the, let's say, public-facing global availability deployment. Because again, remember, what we do is literally API. Like our product, as Coveo or Tuso before, is literally APIs. So the model is the product. Right? We're not like a model embedded in Airbnb. The model is actually the product. So for that, there's an entire, so the global availability stuff, there's an entire, of course, infrastructure that's been built by Coveo engineers over the year. And it's kind of based on our own like internal tooling. It's actually based on Kubernetes, like I mentioned before. It's actually based on Kubernetes, and it kind of was done in a time where past services like, I don't know, Fargate or whatever that is, were less available. For the newer stuff like prototyping and research stuff that we do, especially in my team, we're very happy to use instead like hosted services. So if it's a very simple stuff, we can use, let's say, Fargate on, fast API with Fargate, like, the standard 2-hour data science tutorial that you can find online. For slightly more complex models, we've been using SageMaker because it kind of gives you this Python-based API, so that, if you're using Metaflow, like in our case, you can have a final step in your flow, in your pipeline after the experiment tracking and so on, when you just deploy your models with 2 lines of Python. And it plays nicely with Metaflow because the model artifacts are stored already in S3. And so you just tell basically SageMaker where the model artifact is, and then SageMaker is going to spin up an endpoint for you, which we find is a very good way to iterate and kind of build internal endpoints. SageMaker is not perfect by any measure. Like we find the management of dependencies and custom containers could be vastly improved. But for like, once you get around that, it's actually very quick to spin up something in your Python base code. So that's hopefully answered the part of the question. The second part about monitoring, it's an even more interesting stuff, but it's a newer part for us as a team and as a company, as the monitoring space is being again blooming in the last like 6 months or so. And so we're actually evaluating open source platform SaaS providers in that space, because we actually do something that's very quirky, which is information retrieval. Like most of what we do is either recommendation or search. And so they're kind of use cases that are not the usual one that people mention when they do monitoring. Maybe they mention, I don't know, the loan prediction problem or NLP, but most of our company actually does information retrieval, so it deals with pseudo feedback, and it kind of has a kind of different constraint than most of this. So when we will have an answer, we'll probably publish a blog post or another open source repo to tell you what we think. But for now, the monitoring space is a very work in progress area also for us.
Right, perfect. And I think one of the concerns with I think this is something that Robert also shared in the community Zoom chat right now. It's in terms of companies where it's kind of it's against the culture sort of to allow their data and their processes and things like that outside of this particular stack, say incorporating SaaS and stuff. How do they navigate this particular problem, where their culture relies on just having everything internally, building and deploying and shipping stuff, and how do they sort of navigate this, and how do they adopt that reasonable scale MLOps approach to things?
That's one of the hardest questions there is, because it's a question about humans. It's not a question about Python or
right,
or SageMaker or whatever. It's very hard. Like in my experience working with like dozens of organizations that are our previous customers or current customers or friends that I have all over the industry, the cultural aspect is the hardest one to change. In fact, a lot of the pushback we have with our bigger bot repo or other solution that we put out as open source is like, well, you're lucky because they allow you to do all of these things in your company. But in my company, there's a team for data, there's a team for model, there's a team for deployment or whatever. You can kind of map this into your own experience. So for us, this is the mother of all battles if you can fight it. And we subscribe to the idea of the end-to-end machine learning practitioner, data scientist, or whatever. There is a person that can see the data that has been cleaned and prepared, of course, by data expert, but can see the data, can prepare his own feature, can train his own model, and can ship it out. And everything we do, going back to the thin slice idea, is to empower one person, even one person, maybe more, but it can even be one person, to be able to do all of this and produce business value without ever talking to anybody else, without talking to a DevOps person, without talking to an engineer, without talking to security, without talking to anybody. everything else that is not abstracted away enough so that one machine learning engineer can go from data to endpoint, it's an opportunity for improvement. And the more companies understand this, the more fruit they're gonna get out of their ML initiative. Like one of the problem of company that starts out with a small team of data scientists is that instead of making them embedded into the company, workflow and culture, they put them in like a silo to do notebooks or whatever it is on their laptop. And then after 1 year, we read, Gartner says that 97% of project never made to production or whatever. Like my LinkedIn feed is literally filled with Gartner saying that people never ship stuff to production. So my LinkedIn feed is very boring. But this is kind of, we can say it's the fault of the data scientists, maybe, but we kind of didn't really set them up for success, right? We kind of put them in a bubble and do some magic stuff. And now, whatever magic they do, for us, it's impossible to consume in the company. So my suggestion for people starting up is counterintuitive, but start with very few people and kind of get people that understand the end-to-end value. They don't need to be the best people in modeling. They don't need to be the best people at SQL. They don't need to be the best people in infrastructure, but they understand all of this problem. Okay. So I understand these people tend to be expensive because there are not very many people that actually have done this before end to end. But one or two people that knows what they're doing will make all the next 10 hires like infinitely more productive. If you do the other route, which is hiring 20 people that know PyTorch out of a university, which I've seen that happening like so many times, now you have 20 people that are relatively expensive, maybe less expensive per person, but relatively expensive, that run around to find data, shipping notebook, nothing ever gets done. And now after 1 year, the exec says, well, this ML thing doesn't work. Maybe, for sure it doesn't work like that. But I suggest another approach. When you hire expert people first, you build productivity tool, and then you hire people to actually do the modeling and to kind of, improve on that. So that would be my suggestion for people starting up. But again, this is the hardest battle because it's a cultural battle. It's not like a technical fight.
Awesome. Yeah.
Speaking of expenses, we have another question in chat from Julio. What are the most costly parts of the MLOps tooling and processes for you, whether it's from a time, compute, storage, or other standpoints?
So for us, but that really depends on what you do. For us is compute, in particular is AWS Patch, in particular is GPUs. Okay, so this is for my team, this is the biggest, like in proportion, this is the biggest part of our bill. But that is kind of part of the nature of what my team does. So it's relatively, like either research, like cutting edge modeling, or prototype, still somewhat cutting edge, but still like deep learning stuff, like a lot of data and so on and so forth. Okay, but this is our biggest, like lion's share of our bill will be like that. And the other important part, which tends to be now less expensive, is the Snowflake component. Like all our data is stored in a data warehouse. For us, is Snowflake, and it's what we call single source of truth because we store everything there. Okay, by design. And so when you query a lot, terabytes and terabytes of data, even a reasonable scale, at some point, the bills kind of piles up. What I want to say though is that as much as GPU or Snowflake or whatever SageMaker cost, it's really a fraction of what my time or a time of a person like me cost. Like is a negligible fraction of what an ML engineer, what a skilled ML AI person in the United States will cost. So every minute that I spend on watering of infrastructure is way more costly than pay Jeff Bezos to kind of give it to me. That of course, this is not like, of course, at some point, this analogy breaks down. But again, at reasonable scale, when you have few people, your cost is people. Like your only cost is people. Because if somebody's not happy because they do infra instead of ML, they're gonna leave. And now replacing him is gonna cost even more. Like there's all these sort of hidden costs that we don't take into consideration because it's people cost that are way bigger than your AWS bill, like infinitely bigger. So like optimize for people happiness at the reasonable scale. And then when you really become big, you can kind of optimize for computing as well.
And speaking of people and going back to these early stage ML teams, Piotr also wants to know, would you recommend to go with full stack engineers or more specialized data scientists, ML engineers, software engineers?
For building the MLOps stuff part, I think somebody that understands a bit how the life cycle of an ML model is needed. It may be a exceedingly talented software engineer that had been exposed to, I don't know, come from Netflix or from like that has been exposed to, to modeling as well. It can be a data engineer again that has some knowledge of ML, or it can be an ML person that has some knowledge of data. In my experience, people that are just coming from just a software engineer background, they tend to be very good at some of these tools, but I tend to underestimate some other problems that arise in ML. Typically, think the fact that data continuously change, so the behavior of the system is actually, sort of like a distribution, is not like a linear path, like a normal software. And somebody that is only a data scientist, in the sense of like somebody that is always focused on modeling, may actually underestimate the other complexity, which is how hard it is to make the data be clean, available, and scalable, and so on and so forth. That's why I'm saying I know it's hard to find these people that knows a bit of everything, but in my experience, they tend to be the best people to at least set up a good practice. They're your data leaders, and then after you get your data leaders, you can get people with more specialized expertise to do their job.
Awesome. And I think I'm going to circle back to one point you initially made, and that was like, if you're starting out with reasonable scale MLOps, you be that thin slice, and then start building things on top of that. How do you determine when something should be like should just be a bash script that you automate basically over something very complex, picking up an off-the-shelf SaaS platform, for example, versus just doing something that's very basic or that can just be automated with a with a bash script or something?
I mean, for me, like, very pragmatically, everything everything that works is fine. Like, the guy used to say, perfection is achieved not when there is nothing more to add, but when there is nothing less to take away, right? So what, the least moving pieces you're gonna have, the more robust your system is gonna be. That's for sure. So there's no need to I don't know, to get an entirely new piece of infrastructure if you can just run 3 lines of Python to solve your problem. Okay. What I typically found is that if you got the functional component of your work right, let's say data, cleaning, training, tracking, deployment, and blah, blah, blah. If you get them right inside of these boxes, some of these things may be super easy at first, maybe a small script, 3 lines of Python, whatever. But it leaves you opportunity to grow in the future when these 3 lines of Pythons won't do anymore. So start with the bash script or whatever you do for one use cases, but always put that script or that lines of Python into a pipeline that grows. People are not slowed down typically by what's in a box. People are slowed down by how the boxes are connected together. That's why I'm saying first figure out how the boxes are connected. And then you go into each of these boxes if you want, if you need, to make them better. Okay.
We have a question about a bit of a different topic. Shrikant wants to know if you have any reading recommendations on gaining new perspectives in improving machine learning delivery lifecycle. So any books or?
There are 2 amazing books. So one is already out, is by Ville Tulos, which is a Finnish guy that co-created Metaflow. I don't remember. I don't remember the name on my like on top of my head, but you can find it like easy. And then there's an upcoming book by Chip on ML systems as well. So these are 2 books that I warm-hearted recommended. If you want something to start as an open source available content, Made with ML is a very, very, very incredible resource by my friend Goku. Chip course at Stanford is also open source, is a course on ML system, so you can find it easy online. And a part of my course at NYU is also open source. You can find it on my GitHub. So these are more courses, so slides and kind of snippet of code more than books. but they're kind of free and you can start tomorrow. And the other two that I mentioned are actually books, so you can find them on Amazon, I guess.
Then we have from Chimobi a question about e-commerce. If there is a need to build an image classification model to classify images for about 9 product categories, do we need to build a different model for each product category, or is there another way out?
You mean that, like, let's say I give you, say if you mean I give you a picture of like a product and it's either a shoe or a bag or a t-shirt, let's say, just a fashion example. No, it's just, standard, multi-class classification. There's one model. At the end of the day, there's going to be, 9 possible label, and you just need to get the best label out of 9 according to whatever, model you want to build. So yes, so you can totally, get away with one model. If you're doing image classification in particular, there's some new work, some of which is from my team. You can Google it, on using Clip, so the OpenAI general model, to do classification. So what we did, literally, I think we released the paper last week or something. You can actually use this pre-trained model, this large model from the community, to fine-tune them to e-commerce, and then you can kind of get this classification for free without having even to do any training. So if you're interested in the concept product classification, I suggest you to look it up. Our paper is called Fashion Clip. You can find it on arXiv if you're curious, and we're gonna release the code very soon as well.
Yeah, thanks, Jacopo. And I think I also have a question on scaling, like your stack. For example, maybe I have a use case where I've built one vision model and maybe I'm serving maybe a couple of handful of requests a day. But I know for sure that the models are going to scale, definitely. I'm going to be building models to solve different problems, say up to like 20 models in 1 year. Those probably will be serving millions of requests, for example. How do I think about going from zero, that's small side of things, to reasonable scale, and not breaking things along the way as I go, not breaking my bash scripts or stuff like that I've built?
So I think, so if your concern here is, let's say, future scalability, meaning that, that we're starting with a small data set, perhaps a small feedback, and then we kind of and small serving, and we can kind of increase that over the time. And this is an important point: the increase may not be linear, uniform, meaning that maybe the training data stayed pretty much the same, but now you're serving like 1 billion users because your model is way more successful. Or maybe everything is scaled up. Maybe it's information retrieval, so what you're actually ingesting is feedback data, and so also your training data is going to go up because your serving is being successful. So this thing may not be, maybe slightly correlated, but also may be completely kind of independent. So it's important that your pipeline is able to sustain this independent scaling. So for the data ingestion and the data preparation, let's say a Snowflake solution will give you that out of the box. It will work with 100 gigabytes of data and with 100 terabytes. Okay. The only thing is going to change is your bill, but your code is going to run like exactly as it is with no changes. Okay. On the training side, okay, what you will need to do, let's say you're using Metaflow in AWS Batch, you can automatically scale it up to a certain point just in code, right? So for example, if first you were using 1 GPU, now you can use 4, and it's a negligible change to your code as you progress. So everything else stays the same. And now we got to the deployment part. So let's say day 0, you can even do SageMaker serverless, which is I haven't tried it yet. I know that it's been out for like 2 months or something, but now there's a SageMaker option, which is just pay for inference. You don't even pay when it's not queried. So for the first model, as you said, is like a couple of requests per day, 10 requests per day, 100 requests per day. There may be a super cheap solution that you can use. It's going to basically be free for your first month and so on and so forth. But then when it gets better, maybe you can go into the standard SageMaker with auto scaling. Okay. So it's going to be probably 2 lines of code of difference in your pipeline. And then when you're really at scale, then SageMaker is going to cost a lot. And then you probably have to go into other deployment options out there. Okay. But this is kind of like I think like a kind of an easy way in which you build something that at day 1 work, and at day 365 is going to work literally 98% the same.
Makes sense. And I think looking at small teams, for example, One thing that's very crucial that we've talked about today is, of course, it's an ongoing or ever lasting argument in the software industry, the build versus buy versus open source question or debate. How do you think about what components to say build in-house versus buy versus open source when you're thinking of a reasonable scale or setting up a reasonable scale stack?
So for us, it boils down to, I think maybe because I personally really suck at infrastructure. So it boils down to, infrastructure is always buy. Like anything that is maintenance for me is always a buy at the end of the day. I don't want to, even maintenance in a derived sense. Like for example, my company Tuzo was built on Spark, on EMR and Spark for our data processing.
Yeah.
And I'm one of the happiest person in the world that Snowflake got invented because I don't have to deal with Spark anymore. Okay, like never have to do that again. So that part, I'm super happy to buy all the computing just to get abstracted away all the problems of distributing queries and so on and so forth. For training as well, I can be bothered of spinning up 1 GPUs or 2 GPUs. That's really not a good use of my time. Okay. And in the endpoint, as we discussed, up until a certain point is also okay to buy endpoints just because they are there. Up a certain point, that becomes very expensive. So again, things will change. But for me, always buy computing, like always kind of offload how things are run and maintained and how they scale. Okay. Because at the end of the day, the value of my work is in the line of Python, in my Metaflow step. Like that's what I'm being paid at. Then to do that job, I need to have computing, I need to have experiment tracking, I need to have deployment and so. But my job at the end of the day, like is what I put in those lines, and everything else for me is almost always a buy. I know that I'm on the very extreme kind of like spectrum here.
Yeah.
But again, if you think about how much an ML engineer costs today in the United States and how much cost it would take me to replace it, and how much I'm investing in these people in my team, at the end of the day, again, as much as past solution may cost, they cost a fraction of what my team's happiness actually costed to my company.
Right. And I just have a follow-up question before we look into the community. When you're thinking of buy, of course, we are in the real world, right? Businesses, they have to spend money, and then, you start thinking about the costing, you talked about the talent and so forth. How do you compare the pricing of these solutions? Say, for example, an open source solution that maybe it's hosted in a sub platform, for example, but versus say you're picking a typical SaaS solution. How do you compare? Because you have something you look at. Do you have a framework you use to compare costs in the tools you use for your stack, pretty much?
So there are some of the tools we use that do not have any other like alternative. Like Snowflake is the paramount example. So there's no like the comparison of Snowflake is just you change your architecture. Let's say you go on Spark, for example, and that's big no from what we do. So that's one thing. For other stuff, it really depends on the use cases. Again, SaaS experimental platform, the barrier to entry is very small. They makes the team very happy. So it's a small change in the code base that makes the team very happy. And typically they cost a very reasonable amount of money at the reasonable scale. So you can start with very little. So it's something that I would suggest to buy like all the time. For other things, let's say Prefect, let's say an orchestrator, like it's a very important part of your stack. It comes either open source for yourself or as a platform. What do you do? That is more of a depends again, like what you feel about. Most of these tools have an entry level that is very small on the SaaS side. So you can start with that and then you can always go back. My suggestion at the end of the day is typically start with something. If you don't know what you want, or maybe you know what you want, but you didn't get to the maturity of being able to do the thin slice, to do a new model in one day end to end, which is, for example, where we are at, okay? But you're still starting up, buy stuff first and see if you like them. And then if you really like Prefect and now there's 100 people that want to use Prefect in your company, okay, now maybe we can put it in-house and maintain it ourselves. But let's not put the cart in front of the horses, right? Let's see if we like it first. And then if we like it, we can always decide what to do at scale. That's why I say with SageMaker, like before building your own deployment on Kubernetes, build a model in SageMaker, see if it works, see if it provides value. And after that, you can always go back and redo this in Kubernetes. I think a lot of people are afraid of SaaS cost when actually building stuff up front that you don't even know if you need is way more costly in expectation.
Right.
So start SaaS, and then you can always go back and do something else, because there will be an happy problem. Like if the model that you built is so successful that now millions of people using it, now the problem of scale SageMaker is an happy problem to have. Okay. It would be terrible, however, if now we have taught 2 data scientists how to use Kubernetes, which would take 6 months of salaries to do that, and now the model is not used by anybody. So we waste 6 months of time. These people are going to leave because they're unhappy instead of just buying what is out there.
Right. So again, some questions from chat. Piotr wants to know about the limits of reasonable scale. Like when are you too big for the scale to be reasonable? And do you see it as a matter of team size or amount of models or model accuracy, the relevance?
In our toward data science series that I co-edit with my colleagues Andrea and Ciro, we have a bunch of dimensions that are somehow correlated among each other, but it's not a precise definition, but it's like kind of give you the feeling of where you are. So one is data size, of course. Like if you have a petabyte of data a day, the reasonable scale doesn't really apply to you. Okay. One is the team size. Like until you're like 5, 6, 7, 10 people. Again, the cost, the overhead of maintaining stuff almost never pays off, your team productivity and happiness. So the reasonable scale fully applies. And then when you go bigger, of course, things may change. And the other point is the use case. Again, like I think a lot of people, and I say this, no harm, no foul, but a lot of people kind of overestimate how good their model needs to be at day one to produce value. Like this is a problem for the Amazon of this world. It's not a problem for most companies, and certainly most companies at reasonable scale. Most people that are starting up ML right now, some of the most exciting ML use cases are inside enterprises now. When the bar to beat is an Excel spreadsheet, when the bar to beat, is a clunky workflow. Okay, this is where the value is right now for the most part. If you don't work in one of these 5 companies, okay. So the most important thing for your ML is that it works at all. If it works at all with no maintenance, good monitoring, good scaling, that's literally 90% of the value. So I think a lot of people think they're not at reasonable scale because they're also kind of overthink a bit what the bar to beat is. The bar to beat is provide business value versus the status quo at a reasonable cost. Okay. And that literally qualifies probably 90% of use cases. Okay. Unfortunately, it's not what you read on the internet, right? Like my metaphor is always like, we're all trying to learn how to play tennis. And the only thing we watch is Roger Federer training, which is very inspirational, But A, we're not Roger Federer. Nobody is. And second, even if now we're not Roger Federer, the people that are going to be Roger Federer at the end of the training are still kind of very few of them. Okay. So look at what YouTube does and Lyft does and Uber does. And there's still a lot of lessons there. But then don't really try to map them one-to-one to your life. Because your life, it's very different. And, it's very different in some constrained ways, but also in some opportunities. As in, you can use a lot of tools that wouldn't make sense at Uber scale. Okay.
All right. We have time for maybe a couple more questions. We had a hardware question from Shrikant. So, Jacopo, do you use NVIDIA GPU-powered compute for your model training and inferencing? And if yes, how well are the GPUs abstracted for custom consumption needs across different functions within one model?
So we use the standard NVIDIA stuff that is provided by, through AWS. So both in batch and in SageMaker. So yes, we use NVIDIA stuff, and we are evaluating the use of also NVIDIA open source inference service Triton as the software stack to actually do deployment. Triton comes with SageMaker. These two things are not exclusive. You can have a SageMaker, let's say, powered endpoint, which runs Triton as your inference software. The abstraction is actually fairly transparent. If you use, like we use Metaflow again for orchestration in general of ML part. So when you actually tell Metaflow what to run on AWS Batch, you can point Metaflow to a specific container that you built with the right dependencies. So what happens is you tell Metaflow, hey, run this training code for this Keras model on this container, and this container is proven to run on AWS Batch GPU enabled stuff. Will just run out of. For SageMaker serving is the same thing. A serving instance that that is pre-made for GPUs is going to be automatically work out of a GPU things. So for us, this has been pretty much abstracted away. I have to say that we don't have I don't think we're on the 99th percentile of complexity about the GPU side, because most of our GPU working is for research and prototyping. So it may not be that this setup will satisfy somebody that wants to do GPU serving with very low latency. Okay, so this is a problem that for now we haven't had to have. But for research and iteration, our GPU abstraction with AWS Batch have worked very well, so far.
Cool. And then a question about orchestrating an ML workflow. So Rafael has been using Prefect and Airflow. He's saying, I'm willing to use SageMaker inference endpoints to make model deployment easier. Would you say it makes sense to use SageMaker pipelines to orchestrate the workflow?
I have no experience with SageMaker pipeline, so my opinion here it may not be decisive. So I have experience with both Airflow and Prefect as orchestrators. And if you consider Metaflow as some sort of just ML orchestrator, that's also an alternative. I don't think you're forced to buy the entire SageMaker conceptually before credit card. But I don't think you buy into the whole SageMaker pipeline just to get value out of this. For example, we don't. For example, we don't use SageMaker for training. We find it a bit clunky as an API compared to just normal Python. So I think you can make your judgment, you can make your evaluation independently. There's no reason to jump into the full SageMaker stuff if you don't want to. And on the other side, there's a lot of reason to use SageMaker for things that, for example, endpoints are fairly decoupled from the rest of your orchestration.
Great, and thanks, Chris, for chiming in there as well. Apparently, it can be used block by block with external products. Okay, I think we need to start wrapping it up for today. This was a very intense and informative and great session. Jacopo, thank you so much for answering all our burning questions about reasonable scale MLOps. Thanks to everyone who asked questions. Jacopo, before we leave, where on the internet can people find you and your work?
I'm very easy to find on the internet. So either add me on LinkedIn if you want to see some of our open source demonstration of how this system that we described today are set up. Go to my GitHub, and if you're interested actually in our research and stuff, you can check out on Google Scholar or papers on LinkedIn and so on and so forth. And please do reach out if you want to have a chat. Super happy always to talk about our experience and see if we can help other teams kind of be productive at reasonable scale.
Excellent. Thank you so much. So we will be back in 2 weeks with Kyle Morris this time, and the topic will be optimizing model inference on GPU. So do submit your questions in advance if you cannot make it, and we will see you on socials and in the MLOps community Slack. So until then, take care. Thanks again to everyone, and see you soon. Bye-bye.
Thanks, guys. Bye-bye.
MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. We run it every other Wednesday, and you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.